right, good morning all. Thank you for taking the time to stop by the booth this morning. Hope you're having a good conference so far. My name is Brad Gunner. I am a forward deployed engineer here at Anvilogic, and I'm here today to talk about stopping alert fatigue and the importance of sequence-based detections, what we call threat scenarios. Before I get into that, just a little bit of an overview of the problems that we're solving here at Anvilogic. As we're all well aware, detection engineering is a difficult task. From the point of actually developing your detections to maintaining them and then tracking them over time, that historically is a very manual effort where across the board you're spending a lot of time going through laborsome processes to actually put those detections together to come up with the logic to detect the bad thing. Then you're going through the effort of actually maintaining it, upkeeping it, getting it to a point where it's actually still useful months and years down the line. And then, of course, telling where you are in terms of security posture after you're deploying that content. And then on the logging side of the house, we know this is very costly. To actually put those detections in place, you're going to need data. So you're going to need that underlying data needed for that use case to find the bad thing that you're looking for. And that, of course, is a costly process. Traditionally, the way SOCs are managing this is we're trying to get all of that data into one place, which is challenging on its own right. And that need for additional data continues to grow. As additional technologies are adopted, additional logs are needed by our SOCs to detect those things. Adversaries are adapting and coming up with new threats every day. So keeping up with that is always going to require more and more data, which over time can become a very costly effort to maintain. So with Anvilogic, we're aiming to solve a lot of these problems. From a detection standpoint, we are automating that early on R&D that you're going through to come up with those detections. We have a full library, what we call our armory of content that you can easily go download and deploy in your environment, not spend all that time coming up with those detections on your own. We're going to automatically maintain those detections for you. So at the point that they're deployed, we'll immediately start looking at opportunities to improve the fidelity, come up with some higher fidelity detections based on your environment. We're going to provide recommendations to improve in hunting insights on top of that data. And we're going to continually assess. Just by using our product, you'll start to have what we call your maturity score calculated, which is really your security posture, where your detection coverage relies across the MITRE ATT framework. And importantly, we're enabling you or reducing the need for you to bring all that data into one place. As I mentioned before, it's a very costly effort to get all of your data into one place, get it into a manageable state where you can actually build those detections on it. We're reducing that need by letting you keep the data where it resides and basically propagating our detections down to either those logging repositories or those detection tools. So if you have Splunk or Snowflake, we'll run our detections there. Your vendor alerts for things like CrowdStrike or Proofpoint, we'll bring those right into the platform and not have you need to go put that all into one place. So ultimately what we're trying to do there is reduce the dwell time in between you actually building that first detection and finding a threat later on. So this slide here, it's just kind of showing an overview of the features we do provide here at Anvilogic. Again, today I'm going to be focused on the very top part here around deploying custom sequence-based detections. But if you're interested in any of these features here, from hunt to investigate, tuning and insights, as well as us being your SOC co-pilot, wanting to see that end-to-end detection engineering process that we go through, and feel free to stop by the booth today and learn more. But getting into the topic at hand, though, building those sequence-based detections and why that's so important, we call these threat scenarios. The reason really why this is so important is we've already spent so much time early on in getting that detection out the door, building it, maintaining it, tracking it, that at the point that we're generating alerts, we don't really have time to spare in terms of finding that threat, right? You've already spent so much time, effort, and money getting those alerts in place that at the point that we're actually triaging them and investigating them, we want them to be effective. We want to actually be capturing malicious behavior and finding those true positives, not spending all of our time sifting through thousands of false positives every day. And this is well illustrated by a concept that was published by David Bianco called the pyramid of pain. And what you see here is really just that typical versus ideal detection. And really where a lot of SOCs are focused today is unfortunately on the left-hand side here in those typical detections. These are your very IOC-driven alerts that are looking for very singular or atomic types of events. It could be anything like an indicator of compromise, just looking for a domain IP or a hash, or it could be a malicious process running on a host. The problem with these is that although you do need those at the end of the day, you want to capture that activity, these can end up being very noisy. Just through those type of detections, which are really geared towards the bottom of the pyramid, as you see on the screen there, can generate a ton of noise. You're going through a lot of false positives. That's where you're really coming up with alert fatigue. You're looking at the same alerts every day, which is going to increase the chance that you're actually going to miss some true positives, some actual malicious event out there in your environment. So with lack of context as well, you're only really capturing that singular point in time activity. You don't know what happened before and after. Then you're going to have to go through all these after alert activities to continue to investigate that host or that user or what have you to find out if something truly bad did happen. The ideal state would be on the right-hand side there, or the top of the pyramid, where you're starting to look at the actual tactics, techniques, and procedures that the adversaries are using. So rather than looking at those singular atomic detections, look at the actual TTPs that those threat actors are exhibiting to find that malicious behavior. A very simple example of this would be, you never want to alert on every time Python executes in your environment. Python's a normal thing that you're going to have running all over the place. But if you see Python executing on a host that it's an unknown script you haven't seen before, and then you see some sort of C2 activity on the same host, then all of a sudden it's a little bit more worthwhile to investigate, right? So we want to get to this state where we're looking at TTPs, where it's harder for adversaries to change their behavior. You're looking for that more defined pattern of activity, and there's more strategic value for your detections, right? Rather than have those point-in-time IOCs that will change, you're actually detecting on those sequencing of events that are harder for adversaries to modify over time. Now, with this, right, the concept, what I'm kind of getting toward is that correlation, right? That ability to stitch together individual detections into a higher fidelity alert. That concept on its own is not a novel idea. That's something, many companies have tried to do, many SOCs have tried to do over time. The challenge with it is that's a lot of effort too, right? Then you're spending a lot of time getting your data into a more usable state. You're trying to align disparate log sources together. If you're trying to do that at search time, it sometimes is simply impossible because we're bringing back too much data, and that's going to bog down whatever SIM or search engine you're using. So really, it's just been a very difficult problem to solve over time. But that's really where Anvilogic is coming into play. We take a little bit of a different approach to this, and we effectively try to flip that pyramid. Within our armory of detections, we have thousands of what we call threat identifiers. Those are those low-level, I'd say, more typical detections that you're used to in any given SOC, where it's maybe indicative of suspicious behavior, but it's not always going to be a malicious event on its own, right? Python execution, maybe a bad example, but that's never going to be something you want to investigate every time, right? So starting at the top of the pyramid, we're going to take that raw data you have, run it through our threat identifiers, and start to collect it into what we call your events of interest. That is really your data lake of your results from the detections that you've deployed. Now, on top of that EOI data is where we're going to create those threat scenarios, those sequence-based detections. And the reason why that's possible with the Anvilogic framework is at the point we're storing the results of these threat identifiers into that EOI index, we're normalizing and enriching it at search time so that the output of that detection is aligned not only to our data model, but also to enrichment frameworks like the MITRE ATT&CK framework, Cyber Kill Chain. So you can have all that good enrichment data, all that good normalized output of your alerts in the EOI data, and that's where the threat scenarios are going to be built. So you have all your detections, XYZ in the EOI data. It's all normalized and enriched so that when you're building the threat scenarios, it can actually look directly at the EOI index, not try to pull together those disparate log sources at search time, do it all within EOI, and then ultimately generate a higher fidelity alert, right? So that's what I'm talking about when I say flipping the pyramid. Here's another good example of what this essentially looks like, where on the left, you have your threat identifiers. Those are those individual detections. It can be something as simple as a particular event ID in a process running on a host. Now, we're not going to alert on that, but it's still meaningful data, not only for scenario building, but at the point that it ends up in that EOI index, that's a lot of enriched, healthy data that you can use for things like hunting, additional analytics, all things that we're going to help automate for you. So we're going to look at that EOI data for you. we're going to generate what we call tuning and hunting insights. Tuning insights is the ability to find common patterns in the identifiers deployed to reduce the noise. So effectively make those warning signals higher fidelity. We're also going to look at hunting insights. So that's the ability to bring forward suspicious events from that EOI data itself. These are all detections that you don't want to alert on their own, but maybe there's one anomalous Python execution in the thousands that have occurred that would be worthwhile to look at. So moving forward then to threat scenario, that's where we're building these scenarios on, is that EOI data. Because we've already enriched and normalized it early on, we have the ability to easily build these scenarios without actually having the need to have the, say, expertise in developing that code itself. The way it works within Anvilogic, there's actually a no-code development builder where you can essentially drag and drop. You could go as specific as, if you, going back to that Python example, if you want to look for just Python execution followed by C2 on the host, you can be that simple. If you just drag those two use cases into our builder, we'll immediately start generating the code for you to go detect that. But you can also take broad strokes. I mentioned how we're enriching everything we store in your EOI to the MITRE attack framework as well as the cyber kill chain. You could take some broad strokes and just look for something as simple as MITRE execution followed by C2. Look for any execution tactic followed by any C2 tactic. So that's all enabled just by having that data normalized, enriched in that EOI index before you go ahead and develop those scenarios, right? So in summary here, one of the problems we're solving with this is the need to, or rather reducing the need to massage your data before you ingest it, to normalize it beforehand so that you can create those correlation searches. From a performance perspective, we're running those scenarios on the EOI index itself, which is a much smaller subset of data, so you're not going to run into issues actually executing the search. And then most importantly, you're generating higher fidelity alerts. Now your SOC is no longer looking at those individual threat identifiers, which may be suspicious on their own and sometimes may be malicious, but with the thousands a day, you simply cannot spend the time going through that. We'd rather have your SOC analyst focus on those higher fidelity alerts, which are those sequencing of individual detections together. You know, you could be pulling together. You might have a specific use case you look at where every time that fires, you go through a certain playbook after the fact. You're going to investigate that user or that host or run some additional exposure checks to see if it's normal activity. We say stitch that together into a scenario itself, take those actual after alert activities, bake that into the scenario so that when that fires in your alert channel, you know it's worth looking at and it's worth your time to go find that bad thing. So in a nutshell, that is threat scenarios. I kind of glossed over a little bit of it today, but happy to get more in depth and kind of show you guys how it works in practice. We can build some own custom scenarios on our own. And the last thing I'll note too is that with our threat scenario structure, with our armory, we provide hundreds of scenarios out of the box you can simply go deploy. We also, again, give you that ability to custom build it on your own without needing to know the development language to build that. So that's all I've got for today. Thank you guys for joining us.